Rational and irrational numbers. This is Math 2, Unit 8, Lesson 5. Okay, first we're going to talk about is rational numbers. When I asked my class yesterday, they said this is something they've seen before. Do you guys remember hearing or talking about rational or irrational numbers? Maybe middle school, Math 1 maybe last year. Okay, a rational number is a number that can be written as a fraction of whole numbers. And if it is a decimal, the decimal either ends or repeats. Either or. If you change it to a decimal, the decimal will either go on forever with the pattern 1 2 1 2 1 2 1 2 or 0.333333, or it ends 0.125. All those are rational numbers. Irrational numbers An irrational number is a number that cannot be written as a fraction of whole numbers. And if you write it as a decimal, it is non-ending and non-repeating. It will always go on forever and never end and never repeat. Okay, before I go further, yes or no, you guys vaguely remember hearing about this somewhere. And it's okay if you say no. Do some of you don't remember ever hearing this? Some of you are saying yes? Okay. We're going to talk about examples of each one. Let's do the irrational first, because most kids can remember talking about a decimal that never ends and never repeats. Which one is that? Something you learned a few years ago. What is it? Pi. Do you guys remember that? Pi is non-ending, non-repeating. Yes or no? Yes? Okay. E is another one. That may not be one that you know. E is 2.718. Pi is 3.14. Those are approximations. We use just approximations because these decimals go on forever and ever and ever and ever. Pi is a letter that we use to represent a number, the same with E. You will see E in advanced math for sure, and even Math 3 and advanced math and higher level math classes. Okay, other ones that you may not have known already or didn't realize were irrational is something like this. Root 8. Why is root 8 an irrational number? Is 8 a perfect squared? No. Then if you take the square root of a non-perfect squared number, it's irrational. So root 7. Can anybody give me another example? The square root of? I heard 3 and I heard 5. Would both of those work? Yes? All of those are irrational. Something like this would even be irrational. The cube root of 9. Why? If 9's a perfect squared, is that irrational? Because it's cube root. I'm looking for chunks of 3. Can I break down 9 into 3 numbers that are all the same? No, it's 3 times 3. So it's not a perfect cube. So it has to be the cube root of a perfect cubed or the square root of a perfect squared in order for it to be rational. If it's not one of those, then it's irrational. Okay, Something like this is even irrational. 3 plus root 5. 3 by itself is a real number, but when you add root 5 to it, it's irrational. 3 plus root 5 is irrational. All right. 2/3 would be an example of a rational number. 2 is a whole number, 3 is a whole number. If you were to divide that, the decimal would either be an ending decimal or a decimal that goes on forever and ever and ever, but repeats. Like I said earlier, for example, 1/3. 1/3 is 0.333333, and it goes on forever and ever and ever, but there's a pattern, there's a repeat to it. Okay, even -3/8, it doesn't matter whether it's positive or negative, all of those fractions are rational. What about the number 5? That's not a fraction. Is that still rational? Is it in the wrong spot? Why?
Because you can be 5 over 1.
She said you can make it 5 over 1. Do you guys agree with that? Is any whole number going to be rational? Any integer? Yes, because you can make it a fraction. Okay. Now what about this? I just said no radicals. Why is that one okay? Perfect square, right? Is 36 a perfect squared? What's the square root of 36? 6, and 6 is 6 over 1. Would the square root of 12 be okay to put here? Why would the square root of 12 be incorrect to put? Because 12 is not a perfect squared. Okay. What about cubes? If I wanted a perfect cube, does anybody know a perfect cube? We said 9 is not a perfect cube, but what number is? 8. What else? Not 16. 16 is a perfect squared. Why is 8 a perfect cube? Because what times itself 3 times is 8? 2. Anyone know another perfect cube? 27 would work, because what times itself 3 times is 27? You're giving me another one? 3 times 3 times 3 is 27. Does anyone know what 4 times 4 times 4 is? 64. So the cube root of 64 would work. Does that make sense? Square root of perfect squares, or cube root of perfect cubes, or fourth root of perfect fourth powers, and stuff like that. All right, any questions on this, whether it was a review for you or felt like it was new? Any questions from this stuff, this information? All right, we are going to simplify. Then decide if it is rational or irrational. All right, we're going to simplify and then decide if it's rational or irrational. Okay, number 1, 5/8, and I'm going to change that. Negative 3/5 plus 5/8. Adding fractions, as tempting as it is, can I cross reduce these two 5s? No, you only cross reduce when you're multiplying, and we're not multiplying, we're adding. What do we need in order to add fractions? Common denominator. Where do I always say to put that negative when it's right in the middle? The top. And anybody know what the common denominator is? What can 5 and 8 go into both at the same time evenly? 40. All right, so this time we're changing both fractions. The bottom fraction, what do I multiply top and bottom by to get 40? Was that a 5? So 5 times 5 is 25. What do I multiply on the top fraction, top and bottom by to get 40? 8, so negative 3 times 8 is negative. And then we add just the numerators. What's negative 24 plus 25? Over what's the denominator? 40. You're going to have 2 answers on each one. the actual number answer, and then whether it's rational or irrational. Which one is this? It's rational because it's a fraction of whole numbers. There's no decimals in the fraction, and if I were to convert that to a decimal, it would be either ending or repeating. All right, questions at all on that first one? Do you agree that was easy? That was like elementary school easy. Number 2, 7 root 10 plus square root of 10. What do I get? Okay, we've done these before. In order to add, these two need to be the same. Are they the same? Yes? And I'm adding, not multiplying. What's the coefficient here? 1. I add the coefficients with 7 plus 1. And does the radicals change or stay root 10? 8 root 10. If you have 7 root 10s and you add 1 more root 10 to it, you end up with 8 of the root 10s. So 8 root 10 is your final answer. Is this rational or irrational? And why is it irrational? Because it's the square root of 10, and 10 is not a perfect square. Okay, number 3. 4 plus 7 root 17, close parentheses, plus parentheses 5 plus 3 root 17, close parentheses. All right. We went over one of these earlier in the homework section of the questions. I think John asked for it, and I said, oh, this is a good one. It's been a while. We will be doing it again later on today, and here it is. So, what did I say when I went over it earlier? If there's a plus sign and there's nothing to distribute, what do we do with the parentheses? Take them off. We drop them. 4 plus 7 root 17 plus 5 plus 3 root 17. And combine your like terms. Go ahead and do that now. Okay, 4 plus 5 is plus 7 root 17 plus 3 root 17 is 10 root 17. Can I add those together and get like 19 root 17? No. Is this rational or irrational? If I that part is real, I see that, or rational. But if I add that to it, what does it make it? Irrational. Questions? Okay, next one, 2 root 5 plus 3 root 6. Are those like terms? That's a 5, that's a 6. I'll ask again, are those like terms? No. At this point, we try to break things down and see if any pairs come out. 5 doesn't break down. 6 breaks down, but do any pairs come out? So am I able to add these together? What do you do when they give you a problem, they say simplify, and you can't simplify? Then what they gave you is your answer. If there's nothing you can do to simplify, then that's your answer. Would this be rational or irrational? All right, they're going to ask you questions today, and on the test as well, about adding different types of numbers together. For example, right here, what type of numbers were these individually? Were they both irrational, both rational, or one of each? Individually, they were both rational. And what happened when we added 2 rational numbers together? Did it stay or change? Do you think it's possible to ever add 2 rational numbers together and get a radical answer, an irrational number? No, if it doesn't have radicals to begin with, it's not going to end up with it at the end. So adding 2 rationals will always be what? Rational. Okay, here I'm adding two irrationals, and what did the answer come out to be? Irrational. Here I'm adding two irrationals, and what did it come out to be? And here I'm adding two irrationals, and what did it come out to be? Do you think that's always going to happen from what we've seen so far? It looks like it is. We're going to keep working to see what if I add, say, like a rational and an irrational, like say 5 plus root 3. That's rational. That's irrational. What do I get when I add those two together? That together it makes an irrational. Do you agree? We said that earlier. That's rational and that's irrational. But when you add a rational with an irrational, they're not like terms. That would be your answer, so it would still be irrational. All right, let's try another one and see if what we said earlier about adding irrationals always being irrational, if it still holds. Number 5. Parentheses 3 minus 6 root 5, close parentheses, minus parentheses 4 plus 7 root 5, close parentheses. Is this a problem where I can drop the parentheses? Why not? We have to distribute that negative. The first piece stays the same, so write that down, 3 minus 6 root 5, and then take away 4, take away 7 root 5, and now combine your like terms. Go ahead and do that now. What do we get? Negative 1 minus negative 6 and negative 7 add up to negative 13, and the root 5 stays. Final answer, rational or irrational? Irrational. All right. Let's try another one. Parentheses 7 plus 9 root 5, close parentheses. Take away parentheses 4 plus 9 root 5, close parentheses. Drop the parentheses or distribute the negative? Distribute the negative. 7 plus 9 root 5. Take away 4, take away 9 root 5. Combine your like terms. What do these two add up to? 3. What do these two add up to? Do they cancel each other out? Do they undo each other? So what's my final answer? Rational or irrational? Okay, does this go against what we were saying earlier? It does. So we have to make sure we fully and completely understand. I'm going to review really quick. Adding together all these numbers 2, 3, 4, and even 5. I was adding together two irrational numbers, and every single time I was getting irrational answers. Even over here on number 5, I was adding or subtracting, they work the same way, adding or subtracting irrational numbers, and it came out to be irrational. But what happened on this one here? It came out to be what? Rational. Can anybody make a conjecture, make something that, okay, it's going to be rational when such and such happens? Anybody can look at it and see what has to happen in order for it to become out to be a rational number? You guys think about that? What happened here that was different from what happened on all the other ones? A volunteer? Anyone willing to share? Yes.
The irrational numbers cancel each other out.
When they're opposites and they cancel each other out, is that what has to happen, must happen in order for it to end up to be rational? Yes. Okay, so when they ask you, when you add two irrational numbers together, will it always be irrational? What would you say? No, it depends on the problem. And you can give an example like this because they will ask you to prove it or show an example. This here where the two radical pieces are opposites and they undo each other, you end up with just a rational number. Questions before I move on to multiplication? All right, 1/2 times 3/5. 1/2 times 3/5. What's nice about multiplying? Do you need a common denominator? No, you just multiply the numerators, multiply the denominators, reduce at the end if possible. What does this multiply to? Does it reduce? So rational or irrational? Rational. What was I multiplying together individually? What are these two numbers individually? Each one was rational. Do you think I'm ever going to multiply two rationals together and get an irrational number? No, that's just kind of crazy. I can't end up with the radical if I'm not starting with the radical. Okay, number 8. -3 times root 5. Okay, kind of like what I was asking earlier, except now it's multiplication. -3 is rational. Root 5 is irrational. What happens when I multiply the two together? What do I get? -3 root 5. Is it rational or irrational? Same thing's going to always happen here. If you're multiplying a rational and an irrational, it's always going to be irrational. There's no way that radical is going to undo itself if the other number is rational. Okay, questions before I move on? Okay, 7 root 5 times 2 root 3. We saw one of these earlier during the homework question section of class. What's 7 times 2? Root, what's 5 times 3? Does 15 break down to any pairs? It does break down. Does it break down to any pairs? No. So is this my final answer? Rational or irrational? Because there's a radical and it's not a perfect squared, it's irrational. Now, what type of numbers were these two individually? Are they both irrational individually? And when I multiplied the two irrational numbers, did it come out to be irrational? Do you think it's always going to happen? Anyone want to take a guess? Always going to happen, yes or no? I see a yes out there. Anyone else? Have we ever multiplied and the radical disappear? Think about it. Have we ever multiplied two radicals together and the radical's gone? I see a few nods of yeses. I see a few nods of no's. Can anybody tell me an example of one time we've ever multiplied and the two radicals disappear? Yes.
When you multiply the radicals and the radical becomes a perfect square.
Okay, so can you give me an example?
Like if you do, like, like 5 times root 5.
Okay. She said root 5 times root 5. In the past, every time we've had this, what would we always say? Oh, I see. Oh, yeah. What does this come out to be? Root 5 or just 5? Just 5, because it's a pair. So she's saying if you multiply these two and they come out to be a perfect squared, root 25 is 5. Do you guys agree? Okay, so let's try one, and let's see if I give it to you like this. 3 root 10 times 2 root 10. Individually, is 3 root 10 and 2 root 10 individually, are those two irrational numbers? Yes or no? Yes. Before we even work it out, is this going to come out to be rational or irrational? Can you tell?
Irrational.
It's going to be irrational? Okay, let's check. What's 3 times 2? 6. What's root 10 times root 10 without saying 100? Why is it just 10? Because they're pairs. If it helps you, because we've done this a few times in class, 3 times 2 times root 10 times root 10. Because it's a pair, it comes out. So 6 times what? 6 times what? 10 equals 60. Diego, is 60 by itself rational or irrational? What was it? Rational. Okay. So is this an example where you're multiplying two irrational numbers and it comes out to be rational? Is that a yes? Okay. Now what do you think? Anybody can make a conjecture here. What has to happen here? She said it earlier, so I'm not going to have her say it again. What has to happen here with these two radicals? They have to what? They have to multiply to be a perfect. What's 10 times 10? Is that a perfect square? Now, do they both have to be the same? Thoughts? Let's try. 3 times 12, or 3 root 12 times 5 root 3. 3 times root 12 times 5 root 3. Are these two numbers the same, the 12 and the 3? No. Are they individually irrational numbers? Yes or no? Okay. Let's multiply. Oh, what's 3 times 5? 15. Square root. What's 12 times 3? Multiply it together. 12 times 3. 36. And I always tell you guys, I like to multiply them together to see if it's a perfect square. Is that a perfect square? What's the square root of 36? So I'm left with 15 times 6, which is 90. Rational or irrational? Okay, so when I'm multiplying two irrational numbers together and I want them to come out to be, I'm sorry, I don't know if I said it wrong. I wrote it wrong. I don't know if I said it wrong. What did I say? I don't know what I said. But what is it? Rational. Sorry. Okay, when you're multiplying two irrational numbers and you want it to come out to be rational, the two numbers inside the radical have to multiply to a perfect square. Do they have to be the same? It's nice when they are 10 and 10 or 5 and 5, but if they're different, that's okay as long as they multiply to a perfect square. If they don't, like this one here, it stays irrational. All right, number 12, square root of 75. It's just a number by itself. Can anybody tell me rational or irrational before you break it down? I'm going to say irrational. Why? Because 75 is not a perfect square. Okay, 25 and 3, 5 and 5. What comes out? What's my final answer? 5 root 3, rational or irrational? And how did we know that? Because 75 is in a square root and it's not a perfect square. 13, 10 root 24 over 2 root 3. All right. What can you do with the 10 and the 2? Reduce. Before you guys rationalize, before we multiply top and bottom by root 3, what have I always told you guys to do first if they're both in radicals? Reduce first. Okay, so we know 10 divided by 2 is 5. What's 24 divided by 3? 8. 5 root 8. Do I have to rationalize this one? No. If you reduce first, sometimes, not always, sometimes you eliminate the rationalizing part. Why would I get this wrong if I stopped here? Why would I get it wrong if I stopped here? Yes. You have to break it down. Good job. 4 and 2, 2 and 2, 5 root 2 times 2 times 2. What comes out? 1 set, and 5 times 2 is, what's left in? 2. 10 root 2. Rational or irrational? Irrational. Okay, any thoughts on dividing? When you're dividing irrationals, is it always going to come out to be irrational? Or is it like this here, it depends on if it's a perfect square at the end? It depends on if it's a perfect square. So let's try something like this. 3 root 12 divided by the square root of 3. Am I allowed to reduce these two 3's? Am I allowed to reduce the 12 with the 3? Because they're both in radicals. Should I do that first before rationalizing? Yes. What does that give me? 3 square root of what? 4. Before I go any further, rational or irrational? Why is it going to come out to be rational? Because 4 is in a square root and it's a perfect square. What do I end up with? 3 times 2, which is rational. Good job. questions?